Hello everyone, welcome to a talk on demystifying some myths for monitoring and debugging on Windows containers. My name is Mansi Kulkarni, I'm a software engineer at Red Hat, and I have my co-speaker Ritika Gupta with us today. Both of us are an active member of the Kubernetes SIG Windows community, so you can find us there. So we are going to cover the agenda here. I hope you were able to take a peek at the abstract, but if not, we are going to answer some questions. Firstly, why Windows containers, how to set up Windows nodes on Kubernetes, introduction to host process containers and what they are, monitoring Windows nodes and containers, debugging Windows nodes. Then we are also going to move on to a demo where we are going to do some debugging on a Windows node that we have in a cluster, and we are going to see some container and node metrics on a Grafana dashboard. We will also have some time for Q&A, so keep your questions for that. Let's start with answering the first question, why Windows containers? Many enterprise applications have been built for Windows OS. You may be aware of many legacy applications that we use in our day-to-day lives. And behind the scenes, they use .NET and other Windows-specific APIs. If we want to run these applications in a containerized manner and take advantage of the Kubernetes orchestration capabilities, we need Windows containers. Windows containers allow these applications to be run in a containerized manner without needing a complete rewrite for Linux. A point to note here is that Windows containers are usually tightly coupled to the OS. So you would have a Windows Server 2022 container that can only be run on a Windows Server 2022 host, for example. So once we have the Windows containers, where can we run this? We need Windows nodes for that. So let's move on to discuss where we can bring up Windows nodes. So if you have a Windows VM, which is in a cloud that you use, or you have an instance that is on-premise, you can use those to join as a Kubernetes node to the Kubernetes cluster that you're using. We have quite a few ways of doing that. The first one is KABZ, which is a cluster API provider. Then we have kubeadm, which you may be more familiar with if you are bringing up instances and clusters on your local machine. We also have a Minikube prototype that has been developed by someone from the SIG Windows community. If you have issues or questions running any of these, you can reach out to us on the README that I've pointed to. There are resources for the Slack channel as well. And finally, if you're interested in using a managed Kubernetes service because you're running a production workload and you need someone to take care of your workloads, you have OpenShift, AKS, and EKS, which are going to help you to join your instances to the node as a node to your Kubernetes cluster automatically. So let's move on to discuss the gaps. Okay, so once we have the Windows containers, there are some gaps in our Kubernetes ecosystem that we're trying to bridge. You would know of many solution architects who specialize in Linux containerization, right? They're helping the organizations to re-platform legacy Linux applications and move them to cloud. But do we know of any architects who would do it for Windows? Maybe not. Lack of expertise is a problem in this field. Second, data for Windows on monitoring is scarce, so we cannot create a unified monitoring interface for both Windows and Linux if we don't have this knowledge. Windows Exporter, which is something that we are going to see in a bit, is also not an official exporter that is maintained by Prometheus, but it is created and maintained by the Prometheus community. So we constantly need to improve on that. To give you an example of this gap, in the OpenShift console that I work on and the team that I work on, we had the Linux container metrics specifically hard-coded and for the Linux console that we have. But when we tried to introduce a Windows node, we had to create a Prometheus rules and service monitors which can map these Windows metric names to the Linux counterparts so we can have a unified interface for our customers. To put it in a nutshell, Windows applications are almost always an afterthought, but we think it doesn't need to be like this, and Windows applications shouldn't be left behind in the modernization journey. Let's go over some features now that are added by the SIG Windows community and how they're helping us. So first is the Windows host process containers. Host process containers, specifically in the context of Kubernetes on Windows, are containers that operate as normal processes, but they run on the host machine, and they have access to the host network, storage, and devices. This concept is pretty similar to the Linux privileged containers if you are used to using them. But why are they important? So you see, before we had this feature in place, services like kubelet, kubeproxy had to be run as Windows services on the node itself and had to be registered within the Windows service registry. So it was very difficult to run them. With this feature addition, you have a base image, which is very lightweight, and you can use this image to build any service and deploy it as a daemon set port on the node directly. So it doesn't need to be a Windows service. You would agree that this process has made it come on par with Linux and makes our life very easy. So let's go over some important points why we would need to learn about monitoring. We need this so we can make informed decisions, optimize performance, and strategically maintain cost for our infrastructure workflow, to name a few. OK, let's go over the Prometheus architecture diagram. Many of you may be familiar with this already. But we have a Prometheus server, which is running on the node. This would be a Windows node in this case. It is going to retrieve the metrics. This could be container metrics and the node metrics. It would be kubelet for collecting the node metrics, and a container runtime interface like containerd for retrieving the container metrics. This is usually cAdvisor in the case of Linux. So there's only this container metrics difference in the architecture over here. So these metrics will be retrieved and stored in a time series database and be retrieved by HTTP server. You can use a PromQL query language to visualize the metrics in Grafana or Prometheus Web UI. You can also put some thresholds and push alerts using alert managers. So this comes in handy. And finally, because we are collecting metrics from so many different sources, we need something that will help Prometheus to understand them in a format that it understands. So we are using Prometheus exporters for that. So these exporters are nothing but an agent. For Linux, you may be familiar with Node Exporter. For Windows, we have Windows Exporter. So let's go over the Windows Exporter a little bit. It is nothing but a Prometheus exporter for Windows machines. And we have some collectors. Collectors are nothing but a set of metrics that you can use. The collectors that are enabled by default are CPU, memory, and OS. This may be something that may be suitable for your use case, but other interesting collectors are container and process, and also some .NET collectors. You can enable them explicitly by giving some command line arguments if you need them. OK, so this was all from the monitoring side. Now I'll pass on the mic to Ritika, so she can cover the debugging part for us.
Sure. Thank you, Mansi. Appreciate it. Now, to understand how does one debug a Windows node, we need to understand the components that sit on a Windows node. Windows node in Kubernetes is responsible for running Windows workloads, and it houses several components that enable container orchestration. A few things to note over here. You've got Windows services which sit on the Windows host kernel. These services interact with services like Graph Driver, HNS, HCS. HCS is kind of the host compute system that enables management of containers, and it orchestrates the life cycle on the Windows operating system. HNS is the host network service, and the host network service is responsible for creation of IP addresses for the containers, allocation of IP addresses to them, things like creating the overlay network, so on and so forth. We also do notice that the CNI and HCS shim sit on top of that, and they help containerd interact with the host services on the Windows host. We also have kubelet up there. Kubelet is one of the most important things on any node you need to have, because that's going to help you register this node with Kubernetes. And it's also going to keep a track of what containers are you running, what stage of life cycle they are in, all of that. Now that we understand the key components and how they play with each other, let's take a look into the containers that are supported in Windows on Kubernetes. We have two types of containers. The first one is a process-isolated container. A process-isolated container is a lightweight, sandboxed user space that runs on the host kernel. What we're more interested in today is the host process container. The host process container is extremely powerful, because this container starts up as a process on your host and could access the host network, the volumes, other peripheries that have been connected to your node. There are multiple uses of a host process container, and as Mansi talked about using them in monitoring, we can also use them to debug Windows nodes. Let's move on to try to understand how can we use host process containers to debug Windows nodes. So if you've ever tried to debug a Windows node, historically, we had the struggle of either having to RDP onto the Windows node or doing a proxy jump from the master node onto the worker node. Just a bit of a hassle. It's super cumbersome, copying files over, bringing it back and forth. Painful. That's where host process containers come in. Host process containers are a simple one-line solution which is streamlined with Linux at par at the kubectl debug node command. You just type that in, and boom, you're on the node. You can access everything that's available to the node. The two main benefits of this is reduced complexity, and the second one is synergy with Kubernetes ecosystem. It streamlines the developer experience. It's going to be same on Windows as well on Linux right now. Let's try to see this command in action. So yeah, as you take a look up there, you see that when you use the kubectl node win worker debug command, two things to call out over here. The first thing is we're using the Windows host process container base image. Why is this important? This is a super lightweight image built by SIG Windows that you can use to get onto the node. And the reason this is useful is it's roughly just about 6 to 8 KB and has a very small startup time. If you've worked with Windows containers, you know most of them are not the same. They're usually in the range of 200 MB. Nano servers, the smallest we start with, right? The second thing up there is the custom flag that we're using and the custom YAML that we use. The custom YAML is what tells the kubectl debug command that this is a host process container. We set that in the Windows options. And it also gives us flexibility to use the run as username field to set how this container starts up on your node. So you could change that to anything you're comfortable with and manage the level of access this container has on your host. Wonderful resource on there is the Windows host process container base image repository that I've linked. That repository has a Docker file on how that image is built and how you can build it for yourself, or use that to add on other things and build a custom image. Well, now that we understand how to use kubectl debug for nodes, and we're on the node once you run that command, how do you use other debugging tools to analyze what's going on your Windows node? I've attached a few resources up there. The first one is networking specific. So if you want to debug the host network service, that's a very useful resource with a bunch of toolings and scripts available online. And we're going to take a closer look in the demo on what you can do with it. The second one up there is how do you capture the host compute service traces and logs. And this one's going to be if you really don't know what's going on and you need to engage with Microsoft, you probably would have to go through this route, capture traces, reach out to the support team, work with them, and debug what's going on. A shout out over here to a custom Windows debug image that's available. So if you don't want to add your own tools to the node, you can start with this image. James Stutterwind, who is a fellow SIG Windows member, has published an image that is pre-packaged with a bunch of tools on there. It's a wonderful starting point for someone who's just getting their feet wet in debugging Windows nodes. Well, enough chat. Let's move to the demo and see a few of these things in action.
Thanks. OK, so here we get a list of all the nodes that we have on the cluster. If you take a look at the last two, you can see that we have two Windows Server 2022 data center nodes running on the cluster. We also see that container D is the container runtime that is configured for those nodes. Now let's take a look at the routes that we have available. We have already set up a Grafana route, and that is going to be our URL for the Grafana dashboard. Now let's take a look at the routes in the monitoring namespace. This is going to give us a list of all of the Prometheus URLs that are created. So this is the Prometheus route. We have also already set up some Prometheus rules and service monitors for the path that is /metrics that we are going to see. One thing to note here is that Prometheus metrics for Windows exporters are usually available on the port 9182, which is different from Linux, if you try to get the setup. And now we are going to use the summary stats API. The support for this was also added for Windows nodes, so you can take a look at what metrics are created with this API, and you can see everything in one place. So first we are going to take a look at the pod metrics. You can see the containers that are created, and yeah, you will have everything in one place, which is the memory. You can see the CPU, network, file system, and now we are going to scroll up to the node. So this is the name of the node, and yeah, these are the relevant metrics that you may need to access. And we are going to project the same thing on the Grafana dashboard now. We are just checking that everything is available from the Prometheus side before doing that. So yeah, we are moving to the Grafana dashboard. Let's add a data source. That is going to be Prometheus for us. And now we are just going to use the Prometheus URL that we saw in the routes. And since we are using a HTTPS URL, we are going to set up some authorization headers. So that's going to be a bearer and token with which you have created your Prometheus service. I've used a short-lived token, but you can use another one in your case. This process is very similar to what we would do for Linux, but this is just a demo that we wanted to show. Okay, let's use a dashboard. This is a dashboard that is already created for Windows nodes. This is publicly available, this number, but you can use another one. You can customize it for the things that you want to see in the dashboard. Here you can see everything, the memory, CPU, network, details. Yeah, so that's everything for the Grafana dashboard. And now we are moving to the debugging part. Yeah, so this is the command that Ritika showed earlier.
Yep, we're going to use that and get onto the node. And we're going to take a quick peek into how we get access to the node. All right, you see on there that the container attached successfully, and now you're on the node, and you have access to all the host files on the host file system. That's a quick look into what the K directory looks like. You're going to see all the exes that are available, kubelet, kubeproxy, so on and so forth, configuration files. Nothing too interesting. Moving on to the logs, we can see that we have access to containerd logs, to kubeproxy logs, kubelet logs. This is super useful when it comes to debugging what's going on a Windows node and why containers are not able to come up or a node is not able to register onto a Kubernetes cluster. These are super useful. All right, now we're going to quickly download one of the scripts we talked about that would help us debug the host network service. That's linked up there. It's called collectlogs.ps1. And we're going to run that, and it's going to get a bunch of traces, networking traces for us specifically. As you can see the magic happening, it's going to run a bunch of PS scripts. And we ran them, and it's created a directory out there for us. And that directory is going to house all of the traces that we've collected. Now, we can do one good thing over here. I think we're going to move on to showing that in a bit, is we can copy over the directory using the kubectl copy command from the node to the developer's machine. And this is extremely useful in scenarios where you're looking at event logs that can be analyzed by Event Viewer or WPA or Wireshark, which you cannot open via CLI only access on Windows nodes. All right. We're just copying the logs over. And that's the folder that got generated on the host. Go plug that in. And, well, voila, there it is on the developer's machine. You can see that we have an ETL file which was copied over, as well as the folder. I think it's from an old demo run, the ETL file. You can ignore that. We're going to walk into the folder. All right, sweet. You see the level of networking traces that we've captured. We've captured the namespaces, the ports, the routes, everything in there. So everything that was created when the containers come up that are leveraged by the host network service is in there. And that can be used to analyze if you're seeing packet drops, if you're seeing connections being refused when you're deploying Windows applications on the host. That's the route table. Yep, you see a few ETL files here. We don't have Wireshark right now, but on a developer machine that has Wireshark, you can import those files and look at them, or use the Windows tools which are supported. And that's what the networking TXT looks like. Well, that's a quick example of what debugging a Windows node can look like, and the power that you have to look at the logs that get generated directly on the host. Let's move on and, all right. Well, feel free to reach out to us. That's a summation of our talk. We are available at SIG Windows on the Kubernetes Slack. Those are our LinkedIns. You can connect with us or catch us after the talk if you have any questions for us. SIG Windows is a pretty active community. We have meetings every Tuesday at 9:30 PST. I encourage people to join, and we are always looking for contributors to come help us. Please feel free to scan the QR code to share feedback on this talk. We would appreciate it. We're open for any questions if you have.
OK, thank you very much for the talk. We have time for one question, so if anybody has a question, please run to the microphone in the front. Otherwise, find our speakers around to ask any questions or share your experiences.
Yeah, you can also share your user stories if you have.
Yeah, I think we have one question.
I'll be the one. Y'all were gathering the Windows metrics using Prometheus, right?
Yes.
Did y'all explore OpenTelemetry?
No, we haven't. Yeah.
We haven't yet.
OK.
Yeah.
Thank you.
Thank you.
Thank you very much. And we'll now prepare to the next talk. Please give a round of applause to our speakers.